Hi guys, welcome to this video on quadratic equations and solving quadratic equations through the quadratic formula. Now, the general form of a quadratic equation is, ax squared plus bx plus c. So we've got a coefficient of x squared, which is a. We've got a coefficient of x sometimes, which is b, and sometimes we have a constant, which is c. We'll denote it as c. Now, sometimes you can't factorize a quadratic equation, and like we've seen with completing the square, this will enable us to solve any type of quadratic equation. So this is the quadratic formula, and it says x equals, it looks quite complicated, quite long, but we'll see it a couple of times and we'll get used to it. So the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this formula will prove a little bit later on, but for now we're just going to apply it. So let's have a look at a particular equation. One we can factorize and solve, but I'm just going to go through this particular question through the quadratic formula. I think the easiest way is to write down the a's, the b's and the c's, so you can do a direct substitution rather than trying to figure out what to substitute, because sometimes a negative symbol might confuse us in the substitution. So I reckon step one would be to write the formula, then write down the a's, the b's and the c's. So the coefficient of x squared is 1, there's the a. Coefficient of x is negative 4, and the constant term is negative 5. So negative b, so it's a negative, and b is negative 4. So be careful of double negatives. Then we got plus or minus the square root of b squared minus 4ac all over 2a. So this part is positive 4 plus or minus 16 double negative, which is a positive, so 16 plus 20, which is 36, all over 2a. If you're not comfortable in doing this in your head, you can always use a calculator, but get in the habit of doing these so it becomes quite efficient. Now this, as I said earlier, it's going to be a factorizable quadratic, so this is going to be a nice integer, so 4 plus or minus this, which is 6, all over 2. So we got the two solutions, 4 minus 6 all over 2, there's the first one, 4 plus 6 all over 2. Work out in the numerator and simplify where you can, and in this case we can. So our two solutions to this are negative 1 or positive 5. Verify this by substitution and you'll know that it's going to work, so therefore those are our two solutions. Okay, pause the video and see how you go with this. So we've got minus b plus or minus the square root of b squared minus 4ac all over 2a. There's the a value, there's the b value, there's the c. Substitute, and we end up getting an irrational number, so the third is irrational, so we have 25 minus 8, 25 take away 8, and we have it all over 2. Looking at our two solutions, these are our two solutions. If the question said leave it or just solve it, I would probably leave my solution like this. That's totally acceptable. I'm just writing it in this case so you can see the two different solutions, and here's our approximations to two decimal places. So if I type that into the calculator, there's the first one, and here's the other one. So if you did substitute this into the quadratic, you won't get exactly 0 because this is an approximation. But if you subbed in this value into the quadratic, you would get 0 because that's your exact answer. So there's our two solutions there. Okay, the next one. Same sort of process. There's the quadratic formula. There's your a, b and c. Substitute into the formula, and in this case we don't get a prime number but we get a surd that we can simplify. Like we've done in the topic of surds, this particular square root of 52 is equal to the square root of 4 multiplied by the square root of 13. That becomes the 2, and leave your 13 there. There is a common factor, so in your numerator you've got a 2 in both, so take the 2 out, and then that comes out the front. And once you've got it at the front, then you can simplify, so divide by 2, and what you're left with is -1 plus or minus the square root of 13. I'm going to leave my answer like that. Okay, let's have a look at what it actually means if the thing underneath the square root is different values. Okay, so b squared minus 4ac tells us a lot about the solutions. So what happens if we have a negative underneath a square root? Now we've discussed this before, and a negative underneath a square root is undefined. It doesn't make sense. So for us to get real solutions, if we get a negative underneath the square root, it means that we're going to have no solutions to the quadratic equation. If we have a positive, b squared minus 4ac, there are two solutions to the quadratic equation. There's two of them, and we've seen that many times. And if b squared minus 4ac is 0, so in other words, this section here is 0. So if you had minus b plus or minus 0, minus b plus 0 or minus b take away 0 is just negative b all over 2a. So you end up getting one solution to the quadratic equation. Sometimes we call it two equal solutions or two equal roots. So two equal solutions to that particular quadratic equation. Now, if it's a square number underneath the square root, a square number, so b squared minus 4ac is a square number, you take the square root and you get an integer. So then, if it's a square number, we call these rational roots. You can express it as a fraction. But remember, if it's not a square number and you get an irrational part under, or an irrational part here, like we've looked at in surds, well then you have irrational roots. But we don't have to worry about that too much. Okay, I hope that gave you a bit of an insight at how to apply the quadratic formula. Now later on we'll actually prove that result, and it'll make much more sense in how that exists, how that formula is obtained. But for now, thanks for watching, and I hope you learned something.